Hello everyone, we're Team 2 from Class SGO1, a team of 5 members, and welcome to our team's project, a website offering different tools and filters to analyze temperature and population data. I'm excited to take you through our application and show the many functions we've implemented. The reasons we chose this challenge is because we believe that climate change is a pressing issue in this age, and we hope to raise the awareness of the public by giving them a platform where they can see the changes in our environments themselves. Our website is designed to make that understanding not only accessible, but engaging. Climate change is a complex issue, and we wanted to break down those complexities. Our website allows you to interact with the data, providing a unique perspective on the global impact of climate change. It's more than just numbers on the screen. It's about connecting with the information in a way that inspires action. Now, let's delve into our level 1 of our website. This section is the starting point for your journey, encompassing 2 pages filled with crucial just numbers on the screen. It's about connecting with the information in a way that inspires action. Now, let's delve into our level 1 of our website. This section is the starting point for your journey, encompassing 2 pages filled with crucial information. Here, on the landing page, you'll first see a navigation bar, allowing you to find different sections of our website easily. We also have the website logo in the corner, a way to go back to this homepage. Next up is a banner with a title describing the functions of the website. As you can see here, we have a button right under the title so you can start exploring on your own. This button will take you to the first page of our website, where you can experiment with the data yourself. Down here, we have 2 small boxes listing the range and value of our available data, temperature and population. This information is taken directly from a database, so it is dynamic and accurate and also meets the requirements of the challenge. Just keep scrolling, and what you'll see here is information on the current state of global warming. We added this for a user who wants to find more about the reality of climate change. On the second page, we offer some more information, like from what you can see here, our missions. To continue on, we have some website's functionalities that users can read to find out more about what our website does before they start using it. And just down here, we have our personas, people who might be using this website, from the general public to scientists or government officers. This information is taken from a database, satisfying the requirements of this page. And of course, you'll get to know us, the 5 minds behind this website. This information is also taken from our database.
Next is in the change by country or global section. In the filter table, the user can choose whether the country or global. Here, I will choose country and the start year is 1990 and the following year is 2000. Then click on the apply button. In the table of data, to calculate the temperature and the population, we took the end year and we took the end year minus the start year of the temperature and the same for the population. However, for the correlation column, we took the number of the population of the start year and the end year divided by the number of the temperature, then multiplied by 10 million. Also, the user can sort the number by descending or ascending. Here is the example of our sorting section.
Let's get started. Before we dive into the details, let me provide a brief overview of our website. We have designed it to allow users to analyze temperature changes over time. User can select a country, choose start and end year, along with ranking sort options, and decide whether to view temperatures for cities or states. Upon visiting the page, user will notice a section below the filter options, which is an image of a magnifying glass on documents, along with a sentence filter to display data below. This indicates that data will be displayed in this section once the filter is applied. This also instructs the user that in order to view the data, you have to first choose the filter options and apply it. There are 2 ways to choose the filter options. One way is to just click on a field and a drop-down list will appear. For example, I click on the countries view and it will show me a drop-down list of countries. The drop-down list of country names is sorted in alphabetical orders, and the drop-down list of years will be sorted from small to large for ease of selections. The second way is to just type in and search for the option that you want, and this way is much easier thanks to the autocomplete feature in the search box. I will demonstrate it. For example, I will type in the word uni, as I'm aiming to find the United States country, now the drop-down list is narrowed down into only includes country name that has the word uni in it, and I would choose the United States country, then the start year, and the end year. Also, I would choose to view temperatures by city by clicking on the respective radio buttons, which is city or state, as you can see here. After selecting the filter options, user can click on the apply button to generate the results. It's worth noticing that when users apply the filter, the tables will appear in no more than 1 second, emphasizing the speed of data retrieval. Once the apply button is clicked, the section below the filter options will be replaced with 2 tables of data. As you can see, 2 tables, with its own pagination controls, here and here. The first table displays temperature changes for cities or states within the selected country based on the chosen filter options. As you can see on the screen, this is the first table displaying the temperature changes. Positive changes will be in green color, and negative changes will be in red color, which will enhance user experience by making the information more intuitive and user-friendly, ultimately improving user satisfaction. If no data is available, according to the filter, the section below the filter will display the same image of the magnifying glass with the sentence "no data available" below. For example, let's choose a country with no state data, like Vietnam, and click the apply button. As you can see, when there is no data available, the section below will inform the user to know that there's no available for data for the filter option that they chose. Let's switch back to the United States. The second table displays ranking based on 3 sort options: average, minimum, and maximum. By default, the second table is sorted by average temperature. However, users can switch between these sort options using the drop-down list in the ranking filter. It's important to note that the data displayed in both tables depends on the filter options selected by the user. If the filters options are changed, both tables will update accordingly. The available data spans from the year 750 to 2013, so any selection outside this range will not yield results. And thanks to JavaScript, changing the filter options to view different data does not require refreshing the page. The tables dynamically update based on the user selections, providing a seamless user experience. In conclusion, our website provides a comprehensive analysis of temperature changes for cities or states within a selected country, meeting the requirements for Level 2 Success B. Now let's move on to Level 3, which is Deep Dive Data.
Okay, hello guys, we are going to move to the deep dive session. In this session, we aim to empower our users with a comprehensive view of data changes and data similar across different regions and time period. Yeah, okay, I start with the changes in periods. This segment focuses on comparing the differences of temperature changes across the time periods. One of the standard features of our application is the extensive set of filtering and sorting tools. But what truly sets us apart is our unique selling point. Users can input an unlimited number of years to display on the screen. The flexibility empowers the users to enhance their experience by collecting their specific information. Okay, in this session, we are using multiple advanced techniques to handle the complex data in this session, such as database index for improving SQL performance and Java programming to handle unlimited subquery of starting years. Okay, let's take a quick look at the tool in action. Here in the region dropdown, we will have 4 options, including global, city, state, and country. I take the country as an example. In a time period, I will set it for 10 years. In starting years, I will set it for multiple years like that. And range of average change, I will set it from 0.1 to 3. Range of population from 100,000 to 1 million. Okay, apply. Okay, here you can see the multiple columns represent for multiple starting years displayed just in a table on the screen. And you can see that I can scroll. The second column here serves as a milestone starting year, acting as a reference point for comparing with other columns. The green color of the changes is for the positive change. On the other hand, the red is for negative change. Okay, our filtering capabilities don't stop there. User can also sort the data based on the changes in average temperature by clicking on this icon. I'll test it. Okay, here's the ascending order. And when I click again, it will change to descending order. And here's the pagination. User can click it to access more data if they want. And here's the reset button, and when I click it, it will reset all the filters. Yeah, and here's the notification to handle if the data is unavailable. Okay, let's move to the changes in reason. Yeah. Yeah, this segment will focus on comparing the differences of temperature changes across the regions. Um, in this segment, we also provide the same filtering tools as the previous page, but we will have an input for users to select the specific reason to compare it with other reasons. Okay, let's take some tests for filtering tools. In the drop-down list of reason, we will have three options, including city, state, and country. I take the state for the example. And with the time period, I will set it for 5 years. With a starting year, we will set it for multiple years like that. And in the reason name, we provide an autocomplete input that the user can search the specific reason they want, like that. Okay, I'll take the Shanghai for an example. And with the range, I set it from 0 to 5, the range of population from 100,000 to 1 billion. Okay, you can see that the data will display similar with the previous page. And I also can scroll. Each row represent for the reason, and each column also represent for the selected starting years. Okay, the first row is reference point to compare with other, and the changes here is green when it's positive and red when it's negative. And we can also sort the data by clicking on this icon. Okay, after clicking that, it will change to the ascending order. And when click again, it will change to the descending order. Okay, and we also provide the pagination features that when click on that, user can access more data they want. Okay, and here's also the reset filter. And when we not apply the input for range of error chain like that. Okay, I will set Vietnam, time period, Vietnam. Okay, apply. And yeah, this notification will handle if the data is not available. Okay, that's all.
So, hello teacher, my name is Chuck and today I am a presenter for the last part of this video. So first I will introduce you how the way how our team tackled with the level 3 subtask B challenge. Uh, so as you can see in here we divide it into two parts for help user more easy to decide which data they want to get just at the first step. And for help you more understand how our bay work, we will use the context scenario of Oliver Harry that he wants to get some barriers and country that have a most similar temperature change with the band in the 2000 to 2010. So like any error by of our web, you can list put on any on data in here the filter. We also provide you the autocomplete in region name for help you if you forget just one or two words on some country or city name they can help you. And in here we have the tulip bots. If you want just one get one of each data, you just lead to one bot, and for me I want to get both, so I lead two. So apply, and you can see the data of 10 barriers that have a most similar uh, average temperature with the stack barrier. And by because we fill by absolute values, you can see in here that there are some very similar different that calculate by use temperature minus with the stack temperature with but with relative values. You will see some very interesting percent number in here. This number is represent that this how much percent this barrier different with stack barrier by calculate by use this temperature minus with this temperature and divide with this stack average temperature. So you can and move to similar regions. It have a very same filter with similar barrier, but You can list on Japan in here. By the detail, this is 2000. But you have to very different filter in here. This means you can put how many country you want to get, and this is what with that you want to get is more similar or less similar with your our origin country. And because I choose more similar, you can see in here this is give sending data for all of this value. And but if we list it will opposite in here. So for this subtype, I think the most difficult part is that we need to keep the Japan data in a specific way that we can get it to calculate and compare in later. And for us, we use the table for keep it, and use zone function for get it. So after that, you it like normal data. And for a mod and list similar, we use order function, order by function for sorting it. That on of level G subtype be in our team. So to move to the next part, I will talk about our database. As you can see in my screen, this is our ER diagram for our implement database. I have changed a little it when compared with Milestone 1 is that I move the global temperature data and global population data into the population and temperature table. So for 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 present how it meet with the receivable of ER model, as you can see, our each table of my database is have a memory key, and on of the entity is just they depend on each order or memory key, like how the year, how temperature here depend on memory key and year. And it don't have any logic or relationship wrong between the problem between each order. And I already set the relationship with a relay ISO. You can see I have a tab of relationship. What is the relationship mean? So the reason why we decide it like that is that we need my team one confirm that on logic of between region table and temperature or population table is similar for have other row improve our our code. For example, in here we can avoid to write for SQL query into the table, and but we don't need to write one SQL right here, and set the condition for it if what the region tab the user input. In here we just change the then change the table of region table that's zone with the temperature data, and change the ID of the temperature data that we get from temperature table. So you can see it only in my SQL. In here you can in our temperature table if we have an ID of each round of popular temperature, we have just one ID and identified by the country, local, state or city. So when we want to get the data from the country temperature data, we just need to join with country table, set the set the condition in here, and so on of the temperature will be the temperature data just find the country country temperature data. It's very easy for us and also as well to understand what the logic and give us the answer. So however, this our database don't meet the 3-step requirement because like what I said, the temperature data depend on not only on memory key ID but it's also depend on the year, because since that temperature in this country have a temperature data in this year. So for marking it more, I will separate the temperature data into 4 small table, and set the year like a composite key that need the ID key, the remedy key in resident table for identify the its temperature data, and also it have the same with population. So there is a this is our TNF database, and our also our implement database. And for your listening.
As we wrapped up our tour of the website, let's highlight some technical details that power this platform. Our user-friendly interface, following design heuristic, backed by modern web technologies such as jQuery or Ajax, allows you to seamlessly interact with dynamic data visualizations. Organized database structure combined with powerful backend Java code and libraries ensures accuracy and reliability of the website. Whether you're a data enthusiast or a researcher, Climate Insights are now available at your fingertips through this web app. For Dr. Tung, we would like to extend our best wishes for success in your future endeavors. Your lectures and invaluable tips have been instrumental in guiding us through this project. Thank you for listening to our presentation.